Hello, one and all. Welcome to another lecture on data structure and algorithms. I am JP Sahu. Today's topic for discussion is stacks. Let's start. Stack is a linear data structure. So, what does this linear data structure means? As we know, data structure is a way of organizing all data items that considers not only the elements stored but also their relationship to each other. We can also define data structure as a mathematical or logical model of a particular organization of data item. So as we see here, the data structure is being classified into two types, the linear data structure and non-linear data structure. Array, stack, queue and linked list are linear data structures, whereas graph and trees are non-linear data structures. A data structure is said to be linear if its elements are connected in a linear fashion by means of logically or in sequential memory locations. There are two ways to represent a linear data structure in memory. One is static memory allocation and other is dynamic memory allocation. The stack can be represented in terms of static memory allocation with arrays, and further stack can also be represented in dynamic memory allocation with linked list. The possible operation on the linear data structure are traversal, insertion, deletion, searching, sorting and merging. So all these operations we expect on stack. So stack is a data structure in which the insertion and deletion operations are performed at one end only. Let's have a discussion on stack concepts. A stack is an essential data structure in programming. It behaves like a real world stack. For example, a deck of cards, a pile of plates, or a stack of books. Let's take example of this pile of plates. Think about the tasks you can perform with such pile of plates. You can put a new plate on top. You can remove the top plate. If you want the plate at the bottom, you have to first remove all the plates on the top. Such kind of arrangement is called as last in first out, where the last item that was placed is the first item to go out. So here, stack is a data structure in which the insertion and deletion operations are performed at one end only, which is called as top of the stack. Let's discuss basic features of stack. Stack is an abstract data structure which works on the principle of last in first out. This abstract notion of data structure is defined in terms of the operations we plan to perform on the data. Considering both the organization of data and the expected operation on the data, the notion of abstract data type is very much relevant to the context. An abstract data type in a theoretical construct consists of data as well as the operation to be performed on the data while hiding the implementation details. For example, a stack is a typical abstract data type. The item stored in a stack can only be added and removed. That means inserted, deleted. The last item added is the first item to be removed. We call this insertion process as push operation and deletion process as pop operation. All insertion and deletions take place at the same end. So the last element to be added to the stack is on top, and the last element added to the stack will be the first element removed from the stack. When the stack is created, the stack base remains fixed, while the stack top changes as the elements are created or added. Also, the stack top changes when the elements are removed or deleted from the stack top. The most accessible element is the top and the least accessible element is the bottom of the stack. So we conclude that the insertion operation and the deletion operation can be performed only at one end called top of the stack. Let's have a look on more features of stack. As the items can be added or removed only from top, the insertion and deletion operation is done only from the top. That means the last item to be inserted to a stack is the first item to be deleted from stack. There are two basic operations associated with stack. The push operation to insert an element into stack and the pop operation to delete an element from stack. Let's take the example here in this figure to understand the push and pop operation in this stack. In the first figure we see the stack contains three elements, 2 at base, 7 on top of it and 1 at the top of the stack. Now the stack pointer top points to the element 1 which is on the top. If we push another element 8, then now new top points to 8 because 8 as an element added to the top of the stack. When you push 2, the push 2 process now adds the element 2 on top of stack which was earlier pointing to 8. Now we have new top 2 which is on top of the previous top element 8. Now let's think of the pop operation. In this example, if we do pop 2 operation, it will remove the top element from the stack. The top element of the stack is 2 which is removed and the top item is now 8. Again if we perform top element, that means 8, it will removed from the stack and the new top is 1. Sequentially the process continues till we reach at empty stack as per the user requirement. So now we see the pop 1 operation will remove 1 from the top of the stack. Now the stack top points to element 7. Now the stack base has 2 and stack top has 7, 2 elements in the stack. Now let's have a look on more features of associated with stack. In this regard, we introduce empty stack and full stack. In empty stack, the stack pointer, that means top, points to the next free element, free or empty location on the stack. That means the place where the next item is to be pushed onto the stack. In a full stack, the stack pointer or top points to the topmost item in the stack. That means the location of the last item to be pushed onto the stack. In this figure, we see an empty stack where the top points to the free location, not an element in the stack. Because if we see the stack points to the empty location, if we want to delete element from stack, it goes to a condition called as underflow. That means no element to be deleted. So we can add element to the stack. So in case of full stack, we see that the top points to the location which is the last capacity of the stack. That means the maximum size that can be accommodated by the stack. Here we see the stack base contains element 10, then 20 on top of it, then 30 on top of it, and 40 is pointed by the stack pointer top. The size of this stack as seen here is 4, and here the stack contains all the 4 elements and the stack pointer points to the top. So we cannot add further more elements to this stack. So if we try to add more element to the stack, it shows a condition called as stack overflow. Let's have a look on the operation that we can perform on this stack. Already we have discussed the push and pop operation to insert and delete elements from the stacks respectively. Additionally, we have methods display. The display method or display operation displays the elements of the stack. Now, if we want to display the elements from the stack, we start displaying it from the top. So in order to display the elements, in order to traverse the elements, we have to visit each element from the stack, starting from top till the base of the stack. So now the operations we follow is full and is empty. Is full is operation to check whether the stack is full. If a stack is full, then we cannot add more elements, and we'll go to if we want to add more elements, we'll go to a condition called as stack overflow, which we have already discussed in previous slide. Now we follow another operation, is empty. Is empty operation is there to check if the stack is empty. Stack is empty means there is no elements in the stack, and if you want to insert elements to empty stack, you are welcome. But if you want to delete element from an empty stack, it takes you to a condition called as stack underflow. That means no element is there in stack to be deleted. This is end of the session. See you in the next slide, next presentation. Thank you very much.